Good morning, I'm Yarra. I'll be sharing about my Physics 1 project, where I analyze different movie scenes and the physics behind them. So the first scene is from the 1994 movie Speed, Jumping the Gap. Okay, so in this scene, you can see that the bus jumps through a gap of about 50 feet. So let's see whether this is plausible or not. Okay, so the scene jumping the gap will cover two outcomes, linear motion as well as Newton's law of motion. So let's first find the known variables. Right? The average bus length is about 40 feet or 12.192 meters, and the average bus weight is about 40,000 pounds. And we can see from the movie that the bus is traveling at about 50 miles per hour or 80.47 kilometers per hour. And we can estimate the jump distance to be about 50 feet or meters, 15.24 meters, right? Okay, so in the scene, we can see that the bus inclined upward, almost like a ramp jump. So we need to find the height from which the bus fell. And we can do that by using SOHCAHTOA. So we can find the height from which the bus fell by entering the length of the bus as the length of the hypotenuse, which is this side of the right angle triangle, and 45 degrees as the angle of inclination. So the angle is a bit of an estimate. It's somewhere between 40 or 45 degrees. So I just chose 45 degrees as the angle of inclination, right? So the formula is sin equal opposite over hypotenuse. So we input 45 degrees as the angle of inclination and the bus length 12.192 meters as the hypotenuse, right? So we get sin 45 equal x over 12.192, and we get x is 8.61 meters. So the bus fell from a height of 8.61 meters. Okay, so the total angle of the right angle triangle is 180 degrees, right? So we already know 2 out of 3 of the angles in the triangle, right? 90 degrees here and 45 degrees here. And because the total angle of a triangle is 180 degrees, we know that the angle here is also 45 degrees. So both sides, the opposite of the hypotenuse, and this side is about 8.61 meters, right? Like this, right? Okay, so we found the height of the fall. Now we can use the freefall equation to find the duration of the jump, the time. The freefall equation is d equal vi times t plus 1 over 2 times a times t squared. D is for displacement, which is the height from which the bus fell from. V is for initial velocity, which is 0. A is for acceleration, the gravitational acceleration, which is 9.8 meters per second. And T is for time, which we don't know yet, which we're trying to find, right? So D is 8.61 meters, V is 0. So the equation will be 8.621 equals 0 times T plus 1 over 2 times 9.8 times T squared. And if we do the calculation, T equals to 1.33. So the bus will be falling for about 1.3 seconds. 1.33 seconds. So now that we found the time, the duration of the fall, by using the horizontal travel distance formula, we can find out whether the bus can jump the gap or not. We just need to enter the horizontal speed of the bus in the direction of the jump, right? Okay, so here, we already found the height from which the bus fell from, 8.61 meters, by using SOHCAHTOA, and we already know that the bus traveled about half the jump distance, another 8.61 meters, so the bus only has to cover about 6.619 meters left. right? So horizontal distance equal v, velocity, times t, time. And velocity, we already calculated to be 80.47 kilometers per hour, and we want to convert that into meters per second. And that becomes 22.35 meters per second. And we already know the t, which is 1.43 seconds. So, to find horizontal distance, we just take 22.35 and multiply it with 1.33. And we get 29.73 meters. So, as the bus is falling, it would cover about 29.73 meters of ground. So yes, hypothetically, the bus would indeed make the jump. However, if we go back to the scene earlier, we can see that in the movie, there's no ramp for the bus to jump off. That's a flat jump. So, if there was a ramp, it would technically make it, but since there's no ramp, it won't. So, overall, I rate the scene in RP wretched. Okay, so for the second movie, that'll be Home Alone 2, Lost in New York from 1992, the Give It To Me scene. Okay, so in this scene, we hear Kevin is throwing bricks at Marv. Somehow, Marv is very hurt. You can see that he's still moving around, and he's barely got a visible wound on his head. You'd probably think that he'd be concussed or something, or maybe dead, but no. I could also see that he was thrown multiple bricks, right? He'd probably be dead at that point. So, for the power of physics, we're gonna see if this is possible or not, if it's realistic or not. Okay, so this scene is going to cover two outcomes, Newton's law of motion and work, energy, and power. So, the known variables, we only know two. So, the building height. So, Kevin is throwing the bricks from a 4-story building in New York, and an average 4-story building in New York would measure at about 10 meters in height, and the average brick weight is about 2.27 kilograms or so, right? So Kevin is throwing a 2-kilogram brick at Marv from 10 meters in the air. So first we need to figure out how long it would take for the brick fall from 10 meters to hit Marv, right? And we can find time with the Freefall Equation, which I already explained before. D equal Vi times T plus 1 over 2 times A times T squared. T is for displacement, P is for initial velocity, A is for acceleration, gravitational acceleration, and these are time, right? So the D is 10, and the initial velocity is 0, so that becomes 10 equals 0 times T plus 1 over 2 times 9.8 times T squared. And if we do all the math, we get about 1.43 seconds. So that's how long the brick would fall from 10 meters. It would take about 1.43 seconds. So now we have to find how about we have the direction of the fall uses to find the free fall velocity. So V equal VO plus AT. So V is final velocity, right? VO is for initial velocity, A is for acceleration, and T is for time. So we know that the initial velocity is 0, so we input that as 0. And the acceleration is the gravitational acceleration, which is 9.8 meters per second. And we already found the time, which is 1.43 seconds. So 0 plus 9.8 times 1.43 is 14.01 meters per second. So the brick is going to be traveling at about 14 meters per second. Now we need to find the gravitational potential energy by using the formula Eg equal mgh. Eg stands for gravitational potential energy, m is for mass, g is for gravitational acceleration, like I said, which is 9.8 meters per second, and h is for height. So we know that the mass of the brick is about 2.27 kilograms, and the height of the building is 10 meters. So 2.27 times 9.8 times 10 is about 222.46 joules or Newton meter. Suffice it to say, Marv would be more than likely injured after being hit by bricks multiple times. His skull would realistically fracture, and he could even die from his injuries. Overall, I'd say that this scene is rated PG-13. Physics not that good. Parental that's advised. It's meant for the comedy, so yeah. Okay, so the third movie scene will be from the movie Divergent. Welcome to Dauntless. Okay, so in this scene, we can see that Triss jumps about 9 or 10 floors, landing in a net safely without injury. So, either the net can withstand all the force exerted by Triss when she lands, or it can't. If it can't, and she just falls through the net, yeah, she just falls straight to the ground, basically. So, let's see if the scene is correct or not. Okay, so this scene will cover two outcomes: mutants of motion and work energy and power. So we can see that Triss jumps about 10 floors, and we know that her weight is about 60 kilograms. That's the actress's weight, and she jumped 10 floors, right? And if we estimate the height of each floor to be around 2 meters, that means she'd jump 20 meters. So the fall height is 20 meters, right? First, we need to calculate how long Triss fell, the duration of the fall. We can use the Freefall Equation for that. So, if we input d as 20 and 0 as the initial velocity, we get 20 equals 0 times t plus 1 over 2 times 9.8 times t squared. And if we do all the fancy math, we get t equal 2.02 seconds. So Triss is falling about 2.02 seconds before she lands onto the net. So now we already have the duration of the fall. We can use this equation to find the free fall velocity. V equal V O plus AT, right? So initial velocity, 0. We already know the acceleration, which is the gravitational acceleration, 9.8 meters per second, and the t is 2.02 seconds. So 0 plus 9.8 times 2.02, and we get 19.80 meters per second. So Triss is falling at a rate of 19.80 meters per second for 2.02 seconds. Oops. So we have the speed, we have our velocity, and we also have the duration of the fall. Now we can find the amount of kinetic energy she will be carrying, I guess. So the formula will be Ke, kinetic energy equal 1 over 2 times mv squared. So m is mass and v is velocity. So we already know that Triss weighs about 60 kilograms and that she's traveling at about 19.80 meters per second. So 1 over 2 times 60 times 19.80 squared, and we get 11,761.2 joules or Newton per meter. And if we were to convert that to pound per force, that's about 8,674.62 pound-foot. So remember, the question is whether she'd be able to land into the net safely or not, right? And a normal trampoline, I'm assuming that's a normal trampoline because we don't really know. The movie doesn't specify. But a normal trampoline can support up to 500 pounds of weight. Meanwhile, Triss falls into the trampoline with 8,600 pound-foot of force. Now, I don't know how strong that net is, but It's probably just some makeshift trampoline net, right? And yeah, that net wouldn't be able to withstand that much force. She'd just fall through the net and hit the ground underneath. So I'm just gonna say that I rate this scene an RP. It's pretty wretched physics. Okay, so for the fourth movie scene, we'll be looking at the 1978 Superman. Okay, so in this scene, Lois falls from atop a building. She falls for about 10 seconds, which is, well, the duration of the part in the video, really. And then Superman catches her, right? So, let's see if the physics behind this movie scene is right or not. Okay, so this scene covers two outcomes: Newton's law of motion and work, energy, and power. So in the scene, Lois falls off a building and is later rescued by Superman, right? We already know that. And it took roughly 10 seconds for Superman to catch Lois from the time she fell. So we already know the time. Now we need to find the velocity of Lois, and we can use the freefall velocity equation to do that, where VO is initial velocity, A is acceleration, and T is time. So VO plus AT is the freefall velocity, right? So we know that her initial velocity is 0, and it took her 10 seconds to fall. So 0 plus 9.8 times 10, we get 98 meters per second. So Lois is falling at a rate of 98 meters per second. That's pretty fast, really. Now that we have the time, and that we have the velocity, we can calculate how much energy Lois has by using the kinetic energy, gravitational potential energy equation. 1 over 2 times mv squared. M is for mass, v is for velocity. We know that Lois's weight is 55 kilograms. We don't exactly know that. It's the actress's weight. And that the velocity is 98 meters per second. So KE, kinetic energy, equal 1 over 2 times 55 times 98 squared. So the amount of energy she has is 264,110 joules or Newton meter, right? And now that we have the energy, we're gonna see how much force she'd be delivering. So work equals force times distance. So work is basically KE, right? We already know the energy, and we already know the distance. But we can estimate the distance of a fall, the height of a fall, to be about 20 meters. So F times 20 equal 261,110. So divide both sides with 20, we get F equal 261,110 divided by 20 means that the force she'd be exerting as she were to hit the ground is 14,205.5 newtons. That's a lot of force, right? And Superman is supposed to be stationary when he grabs Lois, which would mean Lois would come to a screeching halt, losing all her speed in an instant. She'd experience so much force that as she lands onto Superman's arm, it'd be the equivalent of her landing onto the pavement below. The amount of force would leave her severely injured. So I don't really think that this scene is correct. I'm gonna rate the scene an RP, wretched physics, not right at the slightest. Okay, so the fifth and final scene from the 2008 movie Hancock, causing a train wreck. Okay, so we see that in the movie, Will Smith, who's playing the main character here, is hit by a freight train. A freight train is a pretty big and heavy train, but despite that, Will Smith is able to completely stop the train in its tracks, derailing it without even moving at all. He didn't even move a finger, and the train just stops. Right. So let's see if the scene is correct or not. So the scene will cover two outcomes: linear momentum and linear motion. So the known variables would be Will Smith's weight. He weighs in at about 100 kilograms. The average freight train weight is about 10,000 tons, or 10 million kilograms. That includes the cargo it would be carrying. And on average, a freight train would be traveling at a speed of 70 kilometers per hour, or 19.44 milliseconds. So not milliseconds, my bad, meters per second. Since we already have the mass and speed of the freight train, we can find its momentum now. P equal mass times V. So P is for momentum, M is for mass, and V is velocity. So the mass of the freight train is 10 million kilograms, and the velocity of the freight train is 19.44 milliseconds. So 10 million times 19.44, we get 1.944 times 10 to the power of 8 kilogram meter per second. Now we need to find the velocity of Will Smith. So P1 equals to P2. So the momentum of the freight train should equal to the momentum of Will Smith. And that the total momentum, which would be P1 plus P2, should be 0. Right? So 1.94 times 10 to the power of 8 would equal 100 times V. V would stand for Will Smith's velocity. So, and if we do all the fancy math, for Will Smith to be able to derail that train, to be able to stop that freight train, he'd have to be traveling at a speed of 1.944 times 10 to the power of 6 meters per second. Now, the problem with the scene is that Will Smith is motionless. He's stationary. He's standing completely still. And because he's not moving, which means he has 0 speed, 0 velocity, that means in physics he has no momentum. Because to have momentum, an object needs to be moving. It would need a velocity, which is why the scene isn't realistic at all. Right? Will Smith would not be able to stop that freight train from just plowing through him. And for that reason, I'd rate this scene an XP. Obviously, physics from an unknown universe, right? Can't be explained. We have to get a better scientist to do it, or someone else. So yeah, that's it for my physics project. Really, thank you all for watching. Peace.